G'day Internet, and we're back today with another secure code review session. Today we'll be looking at a CVE in Exponent CMS, although I first discovered this type of bug through a CTF challenge. And I think the CTF challenge displays a somewhat different aspect of this type of bug, which I think is unique and well worth looking at because it highlights, I guess, a deficiency in how we think about implementing security sometimes. Obviously, I'm going to put the links to all of these things down below, and hopefully at the end of it, I'll get some challenges for the people who want to replicate this or improve their exploit writing skills at the end. But let's start off by looking at the challenge. And it's reduced this vulnerability down to essentially 4 operations. The first one takes a user-controlled string and escapes it. Then we read the content of a file, do a regular expression replace of the string type option equals a quoted string semicolon, and then we write that back into the file. And if we were to look at this file, this is basically what it looks like. It has a string configured as an option. Now, typically, this is the type of pattern you would see in a config file. So WordPress has wp-config.php, and it contains like the database host name, the database username, the database password, etc. And it's often written to a PHP file inside the web root. And the reason why it's a PHP file is that stops these values from leaking through the browser because it's inside the web root. Obviously, the risk with that is that you're writing to a PHP file, and if you can manage to control what's being written in a suitable way, then you end up writing PHP code inside a PHP file that is inside the web root, and you can potentially use that for code execution, which is obviously the goal of this challenge. Now, you might think, well, we'll just put an apostrophe and then we're outside of the string. Well, we can try that. Let's just start by having a look at what it looks like if we update the option. I have obviously a web server running with this code. Just put that inside quotes. And now if we reload option, you see that it now contains the value test. So we can test that theory of what happens if we put an apostrophe in here. Well, it gets quoted, and so we don't escape. We're not escaping out of the string. We're staying within the PHP string because it escapes the apostrophe. But obviously, since this is a CTF challenge, you know that there's a way to do this. And there's really only one operation that matters, right? The first operation is escaping the user input. Well, we can't avoid that. And then the other 2 operations is reading the content of the file and writing the content of the file. So that's not doing anything out of the ordinary. Obviously, the vulnerability has to exist in the regular expression. And it does. And it's a very simple contextual confusion here. And probably the best way to illustrate it is to just simply show you what the payload is going to look like. We'll go back to inserting an apostrophe. And the thing, I guess, the thing to pay attention to here is the regular expression looks for start of an apostrophe, and then an apostrophe followed by a semicolon. And it's a greedy regular expression. If you know what that means, it's gonna match the whole line where possible. So in order to avoid matching the whole line, we'll insert a new line. But we also needed to match the end of the regular expression, which was apostrophe semicolon, new line, and then we'll just do PHP info, followed by comment, because we'll have a trailing apostrophe. And if we run this, we see here that we've written out the apostrophe, the semicolon, PHP info on a new line, but we have not escaped the string. From PHP perspective, this is still just one string. It spans a line, but it's still just a one string. And this is where it gets interesting, in that we exploit it a second time. But this time, we set the value to point. And what happened there is suddenly it has overwritten the escaping, and PHP info now lives on its own. So it's a two-order operation. And the reason why this works is the regular expression doesn't have semantic understanding of the string. So if we go back to this here, sorry, so that what happens is the regular expression comes along and says, here we match the first apostrophe. Is it an apostrophe, apostrophe, apostrophe? No, okay, this is an apostrophe. It doesn't have the semantic understanding that this escape character is meant to escape the apostrophe. So when we overwrite the escaped character with a new string, that escaped character disappears. And at that point, the string is no longer escaped, and PHP info is written in here as PHP. And that's how you get code execution in this challenge. But I think this is an interesting issue, because they are escaping the input. It's just that when you approach it in this multi-step exploitation combined with the discrepancy or semantic understanding between the regular expression and PHP, there is enough wiggle room that you can manipulate the file. Now, obviously, the real vulnerability in Exponent CMS is a little different. And we can start by looking at that. The vulnerability lives inside install index PHP. Now, I've checked that Exponent CMS from GitHub, and I've actually checked out a specific tag. In this case, I did 236, although the vulnerability was reported for 239 and earlier. I haven't tracked exactly which versions are vulnerable, but 236 is vulnerable. So if you're going to play with this yourself, check out the repo and make sure you check out a tag that is vulnerable. It's the latest version, obviously contains a patch. Now, usually when I do bug hunting or research on a CMS or any web app, I will do the installation, and then I do like to visit the install files afterwards to see if they reject a secondary install attempt. Because being able to write to PHP files, as we've seen, is very handy. So here's basically the code. It does a version check, starts some output buffering, allows you to set an arbitrary language, and then initializes a profile. It's possible that that does something interesting, but at this point, I'm basically rediscovering a bug that somebody else has already identified. Now, it's obviously very easy to find something once you know where it is, compared to finding it for the first time. In this case, so we haven't seen any authentication checks. I guess I should add that. That's sort of the important part. And we get to the point here where it's looking for create or update the config settings. So if we have a post value, it checks if the framework config PHP exists, and if that exists, it does some sanitization of the string, and then calls change on the string. Now the config PHP looks like this. So you can see it's a little bit different. Rather than having option equals, it just calls a bunch of defines. And obviously the change function, which we have, will parse the config file into an array and then overwrite the variable or setting and value pair, and then save the values again. Now if we look right above, we have the function for save values. You can see it defines a string as a bunch of PHP, then runs through the values in a pair configuration, then prints out the define for the directives. Obviously, you could potentially manipulate a directive value as well here and have that be malicious rather than just the value itself. Then it calls strip slashes on the value, which is interesting because it sanitized and potentially escaped the value initially before it tried to save it. And then it does some more substring replacing depending on if the directive is a HTML directive. Otherwise, if the directive is not session timeout, sorry, if it's an int, it doesn't do anything. If it's not session timeout, it will replace quotes with an escape quote with the fix me. It's possible it was found from somebody looking at the fix me strings. It's always a good thing to look at fix me's and bugs and those type of comments in the code base when you're reviewing it, and then just writes the file out with the current config name at the end. So the way we would test this, we can take SMT port, for example, or an SMT password. We would do a post, which we saw here on the install. We're looking at post SC, and it's got to be in the array format because it can be seen as key and value. So we do SC SMTP port equals test, and we'll ship that. I have a different service serving this on localhost. We see here that updated SMTP port to be test. So we can again take the usual approach, send it to 27. We see that gets escaped, and if we were to try a new line injection, that seems to work as well. Now the interesting difference here is if I try to overwrite this a second time, because This doesn't use a regular expression to do the change. It reads the file and then overwrites the array. So this isn't string handling in order to abuse this one. And as such, I don't think it's as funny. This one takes advantage of the fact that the saving string replace here will escape a quote with an escaped quote. And obviously the fallacy with that, if you've ever seen this type of bug before, is that there are other special meaning of escape characters, right? So you have escape N for new line, escape A for alert, etc. Sometimes you can do XO9 for hex, etc. But one of the other ways that works is to make a backslash, because backslash is the meta character in a string. You use 2 slashes. Now the code here doesn't have any handling for the backslash. So actually, let me just make this value test first, so it's easy to see what the change is about to be. So if I do a slash 27, now this is going to break the file. Sorry, because I need to meta escape it myself. We can do this. And now that's broken the syntax, because what happens is this one's double escape because it's a string. So I have to meta escape it. We can percentage it, and that way we only need to send 1. So let's just save this, and we can do percentage 5C if I remember correctly. Yeah, because of the strip slashes. Maybe that's the. Maybe it's because of strip slashes. I can't remember. But I was in the wrong spot. Sometimes exploit writing is just brute forcing. Anyway, this works. So now we've broken out. So what happens is this one is seen as just a slash, backslash. This escape. So our injected slash escapes their string replaced slash. So that this no longer escapes the apostrophe, but rather escapes the escape. That's a mouthful, but hopefully it makes sense. So if we go back to a good state here, we can change the syntax a little bit. Then similarly add a new line just to make it nice. PHP info. And you see that the PHP info was successfully injected, and the define statement is successfully defined the string. And now obviously we can go back and even change SMTP port back to 25. And somehow, because it writes it out from an array, that obviously removed the PHP info call and spat out PHP info in here. So you only get a one shot if you try to update anything afterwards. So the way you would use this instead is once you've written to the framework config, you would call it directly as in framework conf PHP. Config slash bit. Lots if you don't mistype it. And there that spits up the PHP info. So there's a couple of challenges that I think might be good for you if you're looking to try to increase handling of this. Is obviously have a look at how the patch was done, and obviously see, can you exploit it in the current version. That might be hard. So I know that they've changed the authentication checks on the install script. However, there may be a way to chain that. I haven't dug too deeply. Maybe some more reasonable challenges would be, can you exploit this in a way that doesn't require injecting PHP? So if you could only inject the letters A to Z, could you still exploit this using a different technique? Also, is it possible to find an injection vector where you don't disrupt the file? So in this case, we've changed SMT port to test, and that would break sending emails. And what if they didn't use port 25? How would you know what SMTP port they had? Are there perhaps other areas of the config file where you can leak the values and overwrite it in a friendly way so that it's invisible? And then lastly is there any other areas of the config file that you can inject without having to deal with the escaping? There's a few different ways, as far as I can tell, to exploit this. So would be great to see people's exploit, post them on exploit.db, post them on GitHub. Feel free to leave a comment down below if you've written one. It'd be good to do. Maybe we can do another breakdown of your exploit and see how it was done differently. Anyway, that's all I had for now. I hope you learned something, and I'll see you in the next one. Cheers.